Today we will be focusing on mathematics last year's grade 12 preliminary exam question paper, Analytical Geometry.
Let's look at question 3, as we are given the diagram below, with triangle as TR, as drawn where R lies on the x-axis, and S lies to the left of RT lies on the y-axis, and the coordinates of SRM and 1, the equation of RT, is to x minus y plus 10 equal to 0.
From the equation of RT, we are going to make y the subject of the formula, giving us y equal to 2x plus 10. Question 3.1. We are supposed to calculate the coordinates of R from line RT. We know that t lies on the y-axis, hence t is the y-intercept. And R lies on the x-axis, hence R is the x-intercept. And finding the x-intercept, we let y equal to 0, giving us 0 equal to 2x plus 10, therefore, x equal to negative 5. Therefore, the coordinates of R will then be negative 5 and 0. Question 3.2. We are supposed to calculate the length of RT and leave our answer in surd form.
Since we already have the coordinates of, or we can then find the coordinates of t, the y-intercept of linear equations y equal to 2x plus 10. By letting x equal to 0, giving us y equal to 10, therefore the coordinates of t are 0 and 10.
By the aid of the distance formula, the length of RT will then be equal to the square root of 0 minus 10, giving us 5 squared, plus 10 minus 0, giving us 10 squared, which is equal to 25 plus 100 inside the square root, then giving us the square root of 125. Hence as 5 root of 5 in simplified surd form.
Question 3.3. If we are given 2 RT squared equal to 5 SR squared, we have to calculate the value of M. And we already know that RT squared is equal 125, giving us 2 times 125 equal to 5 SR squared. Divide by 5 on both sides, therefore SR squared will then be equal to 50. And finally, SR will then be equal to 5 root of 2. And by using the distance formula, we're going to substitute the coordinates of S and R into the distance formula, of which we know that the coordinates of R are negative 5 and 0, and the coordinates of S given as M and 1. Therefore, the length of SR will be equal to the square root of M minus negative 5, giving us M plus 5 all squared, plus 1 minus 0 all squared, giving us 1.
And we already know that SR is equal 5 root of 2, are then going to square on both sides. On the left-hand side we are going to have 50, and on the right-hand side the square root will be cancelled by the square. And we are going to expand and simplify M plus 5 all squared, giving us M squared plus 10, plus 25, plus 1. We will then transpose 50 to the right of the equal sign, giving us M squared plus 10, M minus 24 equal to 0. Factorizing this trinomial, the factors of 24 are 12 and 2. In this case 12 is going to be positive and 2 is negative, giving us the factors M minus 2 and M plus 12, therefore M equal to 2, or M equal to negative 12. And we can see that as the x-coordinate of S lies on the negative side, therefore in this case M has to negative 12, not positive 2,